What's up everyone, it's that Math Magician, and on this video we're taking a look at functions and we're going to see can we find the domain and the range for some graphs of functions, and even if they are functions we're going to determine that as well. So we're going to jump into this problem with two different graphs here, and we want to figure out what's the domain, what's the range, and is it a function? So we're going to start with that one all the way over there to the left. And we're going to start with the domain. We're going to label domain as letter D. D for domain. Remember, domain is the set of all inputs for a given function. So when we think of inputs and we think of graphs, inputs are the x values. So we're trying to determine now what inputs are working for that graph on the left, which inputs are valid, what numbers work here as inputs. And as we move along this x-axis, we can see, for example, at 2 has an output, right? That input 2 gives an output. 4 gives an output. 6 gives an output. 8 gives an output. We see as this line continues, right, to move in the right direction, right, going to the right forever, all the way to infinity. It's a line. It's going to keep going on forever. So to the right, it's going to infinity. We see also to the left, it has that arrow there. All of those sets of inputs are going to work and give us outputs. So for a line, we can always know this, right? For a line that's not vertical, vertical would be different. But for any other type of line that's not vertical, the domain is always going to be negative infinity, right? Because we know that direction is going on forever in the negative direction. It's going to go there for 2x, and then x is going to go to infinity. That is the domain. That's how we list domain. Domain is how far left does the graph can go, how far right does the graph go for a set of given inputs. That's one way to write it, right, with inequalities. You can also do it with set notation. I personally think set notation is a little easier. So if I was using set notation on this guy, I actually would write it this way: negative infinity to positive infinity. But because we're not including infinity, right? Notice that these inequalities here do not have the equal sign. We can't actually hit infinity. Infinity is not a number. It goes too big. So we would put parentheses. So you can do the inequality way. You can do the set notation way. Either way, it's giving us the same information. Alrighty, let's go ahead now and try range, right? If we think about domains, the set of inputs that work for a given input or a given function, right? Range is the set of outputs that work for a given function. Again, domain is thinking left and right. Range is thinking up and down. So we want to look at those outputs and see which outputs are possible. And again, for a line, we notice as we look at these y values, it's going to keep going up, 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 up forever until it hits infinity, and it's going to keep going down, 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 all the way until negative infinity. So what's our range going to be? Well, it's going to be negative infinity. We're not putting x's now. We're putting y's. For range, it's always a y, all the way to positive infinity. That's the way to write it. Again, if we're using the inequality way, if we're using set notation, notice that it's actually going to look exactly the same as the domain was. Okay, so for that first graph, we know the domain and the range is both going to negative and positive infinity. All right, let's try this guy. I hope you notice already that this is different than the first graph. This is not a line. It looks like two lines put together, but this is not linear, and that's going to affect the domain and the range. Now, I want you to think about this, though, as we set this up, right? For the domain. Domain is the set of inputs, right, that work. Domain is left to right. Look at those x values. Is there an x value here that does not have an output? And I think when we're looking at this graph here, I think we're good. I think every x input is still going to work for this, just like the line on the first one, right? I see over here that this line is going on forever in both directions. Everywhere in between that, there is an output for that input. This domain is actually going to match the same one we had over there. So I'm going to write negative infinity. It's going to be less than x, which is going to be less than positive infinity. Okay, again, if I want to use set notation, I'm writing it this way. Really, really good. Alrighty, now here's where it's going to change, and I hope that for this one you understand where it's going to change, okay? Again, range is the set of outputs, all possible outputs. We're looking at this graph. We notice that the arrows are both pointing in the up direction, which means the y values, right, are always going to be going to positive infinity. So that means, right, over here, we know that that upper bound is going to go to positive infinity. But as it starts to come down, as it starts to make that V, do we see that the lowest y value is right there at that vertex, which is at -2. I hope this starts to make a little sense for you. For this graph, -3 is not a possible output. Do you see that the graph does not exist at -3? And it also doesn't exist at -4 or -5 or -6 or -7. It doesn't exist for any values less than -2. So how do we write this? Well, let me put that y in there. We would say that the outputs are going to exist when y is greater than or equal to, because it works when it's equal to -2. Okay, I hope that makes sense in your brain a little bit, right? Range is always how high, how low. The lowest point, it doesn't get any lower than -2. That's why this is our range. And let's go ahead and do our set notation. Our right bound is still going to be positive infinity. The left bound, it would be -2. And since we're including -2 and it has that equal sign, we would say the set notation is going to have that hard bracket there. Alrighty, y'all. I know domain and range can be a little tricky for you, but just remember this trick, right? Domain is set of inputs. How far left, how far right. Range is the set of outputs, right? How low and how high do the graphs go? All right, we're not done yet. You probably thought we were done, but we're not done yet. The other thing we got to say is, are these graphs functions? Well, we're looking at the first one. This is definitely a function. How do I know so quickly? It is a straight linear line there, and it's not vertical. That is for sure going to be a function. As I look here at this graph, I can also say that this is going to be a function because it is two lines that are put together and it's not overlapping, right? Remember, if you ever have a graph that overlaps itself, it fails that vertical line test and it ends up not being a function. This does not overlap itself, so it is a function. Awesome, awesome job, y'all. It's That Math Magician, and I'll see you on the next video.